everyone. I've been informed that we should keep this in English, right? Yeah, so your Romanian is not that great. Okay, yeah, it's fine. We'll keep it in English. It's fine. So, welcome to the 40th edition of Sibiu Web Meetup. My name is Stefan. I'm the host and organizer of this event. As you can see, if you want to learn more, you can scan the QR code. If you want to apply for to become a speaker, yeah, you can also scan the QR code. This will be the last event of the summer. We'll take a short break for July and August. We'll come back in September with fresh forces. Today we have Ale here, who's going to talk about architecting the future of web apps. And that's about it from me. I'll hand it over to him. Thank you. I'll say a few things after the talk, but yeah, I'm good. If you want snacks and beverages,
yeah, take 2 minutes until I switch laptops if you want drinks, and then you better be here. Alrighty. Ia, stai așa, că tu mă fi partea asta. One more minute. Welcome, Alex. So before I actually start the presentation, I would like to get a little bit of a temperature of who am I talking with, like what are your backgrounds, and so I can better mold the presentation overall to the audience. So keeping in mind that we're talking about web apps, how many of you out here are in software engineering? General software engineering for now. All right, so everybody. I'm good. I'm with the right audience. All right, how many of you have built a web app of any nature so far? Okay, good. Right. How many of you have built a complex web app, single page application, multiple interactions, event streaming, and so on? All right, I'm with the right audience here. So you're going to find this fun. Otherwise, it would have been less fun, I'm guessing. But we'll see about that. So, my name is Ale. Today we're talking about architecting the future of web apps. It is a story about how I built a really complex project, and I'm going to tell you in a little bit about it. Thank you so much for coming today, and I'm hoping this is going to be entertaining. Just with every presentation that I'm doing, I like to set up a little bit of context. So I'm going to go quickly through the chapters. If, as you're seeing these chapters, it doesn't seem like the right place and fit for you, that's perfectly fine. I honestly don't mind you getting up and leaving. That's perfectly OK. Also, during the entirety of the presentation, feel free to just raise your hand, and I'm happy to stop and deep dive into anything that I'm showing here. FYI, it's a lot of info. I've compressed it a little bit, and we're going through a lot of things in here. I'm going to try to skip some of the statistics because they're not as useful as the actual exercises at the end. But let's see how all of this goes, all right? So we're going to talk a little bit, just some context on me and why you should be listening to me if you decide to listen to me. So what are we building? What were we building, basically? This is from my previous company where I built a product over there. What's the tech stack? A little bit of a flashback on what are the challenges that we've encountered. We're going to look at the critical path for this particular app and how we thought about it. We're going to rewind, draw the whole picture, and then we're going to deep dive a little bit into multiplayer and some other pretty cool stuff, I think. All right, about me. I'm Aleodor Tabarcea. I'm currently an engineering manager at Snyk. For those of you that don't know Snyk, it's a cybersecurity company. But today I'm going to be sharing with you a lot of the product, about the platform and product that I've built over here at Adobe. I'm going to come with some cool stuff from Snyk as well, but I'm still like amassing it and putting it together. Previously, I've worked with Bitdefender and with Microsoft. With all of them, I've been mostly oriented towards building web application, and they got more and more complex as I went along. This was by far the most complex one that I've built, and that's why I'm sharing it with you. So what were we building? 3 years ago, I don't know how many of you are familiar with Figma, right? All right, you know Figma, right? So 3 years ago, Adobe was in this place. They were like, holy shit, Figma is growing. Before they decided to acquire it, they were like thinking, what are we going to do about it? Let's pick a bunch of people and just throw them out there and see if they can build something for the web. They had this initiative around 7 years ago, trying to build something for the web. They got an MVP up and running. If you're familiar with Adobe XD, which was the designing platform that they were running like a couple of years ago, it's still running, but it's not as actively maintained as before. So they tried to port that over to the web and see if they could do an MVP. They successfully did the MVP, and there was this really great guy, director of engineering, that said, there's no way anybody would use a design tool on the web. Couple of years later, Figma comes along, kind of proves that entire theory wrong, and we're starting to figure out, like, holy shit, we're going to be left behind if we're not doing something about it. So I had the opportunity and pleasure to be one of those first engineers that started building the POC for moving initially Adobe XD, then it became Adobe XD, Photoshop, Illustrator, and everything else towards the web. So what did we build in order to figure out what's the MVP or like the minimal usable product that our users will love and load if we delivered it? We decided to build something that we called the canvas. The canvas was supposed to be this multi-dimensional, just one screen where you could drop everything from Illustrator to XD to Photoshop files to Google files or whatever else. You would just drop them in there. They would get rendered so you could preview them. And you could tweak a couple of things on them and just add like a text, a circle, a rectangle, and so on. Now, in order to be able to do this, we did some marketing research and we tried to figure out, like, would anybody use it if we build it like an MVP? And the decision was that, yes, they would use it, especially the marketing designers, which had like a shit ton of resources that they had to arrange and prepare for a marketing campaign. And they wanted to make it somewhere that they can visualize it all, right? Like have a bird's eye view on all of the resources that they had for a particular campaign. This is what we were aiming for. But we're going to go a little bit back, and we're going to say, like, OK, at first we were like, nah, this doesn't look so hard, right? Like the UI there is trivial. And me building web applications up to that point with classic APIs behind them, I was going very noob-like into this world and being like, yeah, what's so hard about building an editor? But then we had a couple of problems at first sight. The first one was that the main thread just cannot keep up with the number of updates that we wanted, right? Whenever designers started to interact with our tool, they want crisp, instant reaction to everything. They want 60 frames per second, most of them, and they can actually tell if it's not 60 frames per second. I'm not sure I can tell, but they can definitely tell that it wasn't, right? So after just throwing some random resources on the main thread and just putting the resources in there, I hand it over to a designer, and he looks at it, and he's like, this is shit. So we're like, OK, why? And he was like, see, when I start moving this rectangle over here, the first 2 pixels are not moving at the same time with my hand. And I'm like, what are you talking about? Anyway, he was right. Like, we had a definite lag between the moment that we were starting to basically raise up events to the moment that we were actually moving the rectangle on the canvas. So we started figuring, like, OK, the problem is that all the UI that's taking the resources on the main thread is actually bottling up all of the processing that we have to do on the rectangle itself, right? The second one is multiplayer games are a pain in the ass. As soon as we got like 4 or 5 people working on the same thing, and they were all drawing rectangles or changing the colors of the same thing, they were trying to overlap one another, we figured out, like, how the hell are we going to solve all of these conflicts? So that was problem number 2. We're going to talk a little bit about it. Problem number 3, patterns for scale. As I was telling you, initially it was like, let's build this really nice canvas with a couple of tools. And then there would be another engineering director that would come in and say, why don't we build everything in Photoshop on top of it? And then the guy from Illustrator was like, yes, this is a great idea, but let's throw everything from Illustrator in there as well. And Adobe Acrobat Reader and everything on top of it, right? So we were just thinking at that point, okay, we started building this, but we actually need to think a little bit more towards the future than we were initially expecting, because they're expecting a lot more from us. They're actually expecting more of a platform, not necessarily just a product. The next thing, bundle size is hard to manage. I don't know if you can imagine, but all of the tools in order to actually manipulate the images, the rectangles, the text, and all of that, they take a ton of space. That's why Photoshop is like 28 gigs right now, and I believe Illustrator or Premiere Pro are already over 35 gigabytes, right? So we had to figure out what the hell are we going to do? How are we going to move 35 gigs of tools, resources, and way of processing data over to the web and actually make it useful and snappy and real time for the user? Working with the latest technologies is great until it's not so great. We were trying to deliver this initially for all the 4 major browsers, basically Edge, Chrome, Safari, and Mozilla Firefox. Until we actually met the developers from Safari, then we decided we don't like them. So we're not going to do that with them. We pushed a little bit more. Chrome and Mozilla were actually happy to support us. The realistic problem with this tool being built is that a lot of the underneath ecosystem that we needed was just not there. So for example, you want to do color picking on your device. Well, surprise, Chrome, Mozilla do not support doing color picking outside of your web page, right? So if I want to have 2 web pages, one next to another, and just go to the other one in order to color pick something, I wouldn't be able to do it. So we started going to them, and we started building together and designing the new APIs that we would need in order to deliver this to our clients. All right, questions so far? This is just like the introduction. I have a lot more, I promise. Okay, so what's the tech stack? I'm just going to quickly move through this. We first decided on React, TypeScript, and C++. So let me give you a little bit of background on each of them as to why. React was the UI part. Why? Because I knew React. Honestly, that was the decision. The second one, TypeScript, it was why? Because we had a lot of C++ developers that were joining, and they were looking at JavaScript, and they were like, hell no. They didn't want to touch that, right? So we were like, okay, we have to go a little bit of a middle ground here. So we're going to move towards TypeScript, so you can actually give the type safety of a language. But we still have to deliver all of this to the web. So it still has to be JavaScript underneath it, right? We could have, of course, as they suggested, built everything in C++. And if we did that, we probably wouldn't have had this talk today because we still wouldn't have finished the MVP state, right? All right, cool. So this was like the initial thinking that we had. The next challenge that we had, was figuring out what it would be the state management machine. How many of you are familiar with state management machines? A couple of you. So just to give you a brief introduction, state management is basically behind your UI, behind your business logic, behind everything. There is this database that you get in regular backend, but there's also a database behind all of the UI, right? It's just represented differently inside the browser. So inside the browser, at that point, I know that at this point, like a year and a half ago, because it's JavaScript world, there are a couple of new technologies, but state of the art at that point were MobX, Redux, which continues to be super popular, and Xstate. So, because we're a big company and we have a shit ton of money and we can spend it on our developers, we were like, okay, we're going to do a POC about this. So we started building something, which was, we tried to build the minimum application that would somehow reflect how a user would build with Adobe Photoshop or with the canvas, right? So we wanted to see what would it mean with each of these state management machines to bring 100,000 nodes, pictures, text, rectangles, persons, whatever else, onto a canvas and draw it. Not make it interactive yet. Remember, this is just an MVP. We're just trying to make a point here. So we started to figure out, and that's why I told you I'm going to go quickly through the statistics and just let you know what the result is. But we tried to figure out, like, OK, based on these state machines, what are the most important things that we have to see? First one was the first contentful paint. This is generic for the web. You actually want to see something as fast as possible. The second one was time to interactive. How much time until I can actually click something and it's going to respond to me. But the next ones this is something that you usually don't hit up. So for those of you that build web applications, have you ever looked on the estimated input latency or a memory footprint of your applications? Yes, I see a nod there. What were you working on? Sorry, Unity web apps? Nice. We're going to have to talk in the networking area afterwards. All right. So basically, the estimated input latency was how much time does it take for the information to leave from my Canvas main thread, go all the way to the backend, which was another thread. We're going to talk about it a little bit later. Behind the scenes, that would serialize and deserialize some information, take it from the second thread, bring it back to me, and show it to me, right? This is where, like up until this point, we weren't really convinced by just keeping MobX. But you're going to see a small surprise over here. And the fact that the estimated input latency for this, for MobX, is going to be like 358 milliseconds. And for Redux, it's going to be 320, and X8 320. The reason behind this is like going into the weeds a little bit. But MobX uses proxy behavior behind the scenes. So they have a proxy on top of it, which they actually managed to put, and this is why the small latency here appeared whenever we had our interactions. And you would be like, yeah, but like 358 milliseconds versus 320, the difference is too small, right? Of course it's too small. But as soon as the user started dragging something, all of those milliseconds, couple of milliseconds, they were just adding, and they were just creating a huge backlog of lag for us, right? So that's when we were looking, and we were kind of deciding that MobX, which was our preferred option, is no longer looking so good. But then in came memory footprint, and this is the last boring one that I'm going to be talking about. And the memory footprint was actually off the roof. MobX, whatever they do, is they don't create getter and setter functions for anything, right? They reuse that proxy mechanism that they're using on top of their objects to intercept everything, and you can just do like object.something equals something. The proxy is going to fire in the background, and it's going to do all the magic of getter and setters for you. So it's actually not going to create that behind the scene on your objects. So that's why the memory footprint on this was actually a huge difference. In Redux, having to just write those functions, those setters and getters, and make sure that they pipeline, they were adding that much more overhead onto our functions, which again, for this very simple example where we were just doing 100K layers in the application, it was just like between 87 megabytes and 23, right? But what happens when you get to 1 million such instances? The average Photoshop document out there in the world has approximately 902,000 objects saved on the document itself, right? So that's the kind of load we were actually looking for. All right, so long story short, we picked up MobX mostly for the memory footprint here. The other ones were doing better in terms of actual processing. This is like bigger than expected. We are actually adding MobX. Our C++ developers were not happy about it because they had no idea how that was working behind the scenes. We kept TypeScript, but oh, I did a boo-boo. No worries. We kept TypeScript and C++, but another problem came around. The memory footprint of React with 100,000 nodes was absolutely ridiculous. So we moved on, and we started comparing a couple of other things. Let's figure out at the moment of this experiment, there was React, there was his smaller brother, which was Preact, and they were saying that they're going to be doing a better job than React, but with a smaller footprint. And then there was Lit Element, which is like the closest to the browser, to the metal, as you can possibly get in order to build an application, right? So we started, again, because we're a big company and we have enough time to play around, we did another MVP where we tried to figure out like what is the best technology framework in which we could build our application in order to have the smallest possible footprint. As you can possibly see from the results, Lit Element was kicking ass at this point. So for the complexity that we were looking and a growing number of elements on the dashboard, this is again for 100K elements, just shown on the page over there, and did some comparisons. And Lit Element, being so closer to the metal itself and using web components, which is a web standard now, was doing a lot more better. All right, we talked about the tech stack. I'm not sure about timing. Can you keep me on timing? OK. So we talked about this tech stack. We picked up MobX, TypeScript, C++, and Lit element. This is how the entirety of the rest of the application in which we're getting into the architecture now was built. Let's talk a little bit about the critical path of the app. Oh, questions so far, curiosities. I'm looking for raised hands at any point, honestly. No? Yes.
How do you manage to learn that new framework?
That's the beauty of it. You don't have to learn it for a POC, right? Because in the POC world, that beat us hard later on. But in the POC world, you just figure out like what is the most used element in my page. I'm going to replicate that 100,000 times in our scenario. We're just going to make it the best that we can. So I'm just going to learn this very small scope the best that I can. And then we're going to do it across 3 or 4 or 5 technologies. Beyond just what I put in here, we also tried with Vue.js, which was absolutely ridiculous from memory footprint. Like it was almost 3 times bigger than React. And we also used Svelte, but Svelte proved to be very young and very unstable. And it was a very weird bug at some point where you had the canvas where we were drawing the elements, and you would press a button and the canvas would be erased. Nobody figured out why. It was just some random bug on their side. But it took us like a week, and we were like, are we going to debug Svelte in order to figure out how to build our app, or are we just going to drop it and move to something else, right? So to answer your question, you don't have to learn each of the frameworks in order to figure out which one is better. You just have to learn like what's your most common use case, get that, experiment with it, and just do some comparison. Does that make sense?
Yeah.
Yes.
Have you considered using WebAssembly or functional-oriented frameworks like Elo?
Yes, we have. So actually, wait. When I talk C++ over there, I'm not exactly sure what I did, but I'm going to just go back. So when I talk C++ here, this is all WASM behind, right? And I'm going to go through the bigger architecture, and I'm going to explain to you exactly where WASM comes into play. We did have, at some point, we were very close to making the decision, OK, we're going to drop everything web, and we're just going to do WebAssembly, like C++, UI, and everything. And we're going to use some higher level language just for the UI and stuff. But surprise, surprise, if you use WebAssembly and you make everything perfect, it's non-accessible to anyone. Because all of the accessibility that comes with the browser packed out of the box, like all of the elements such as buttons and so on that get read by accessibility readers, and especially if you're targeting education area or general, how do you call it, state government. If you target government or education, you have to have accessibility in place in order to cover all of your use cases, right? So for Adobe, a big company, that was a total no-go. We could have built it probably faster, more responsive and everything just by using WebAssembly overall, but we would have lost everything around accessibility and the common pattern usage. You could have, of course, built an accessibility framework on top of WebAssembly, but good luck with that. Call me 10 years afterwards, right? Cool. Let's move on a little bit. I got sidetracked here. We're going into the critical path of the app. So it all starts with an index.ts, the simplest of them all. But this is where the first kind of anomaly into our regular workflow appeared, which was preloaders. I'm not sure if you ever used preloaders so far. The concept of a preloader is basically to make sure that all of the critical resources for the path of your applications are loaded before you do anything. In a regular app, you just bring in your JavaScript bundle and you start building elements, components, whatever you want, right? For us, bringing in that bundle or that WebAssembly bundle was a very expensive thing, both in terms of traffic but also in terms of just downloading it to our consumer's machine, right? So we decided, OK, until we know absolutely for sure that this consumer can actually run the app, has all of the rights in order to be able to put this together, like entitlements behind the scene, he's paying for our bundle. Well, it was free at that point, but we were preparing for the paying tier and so on. So before we know that everything is in place, we're not going to do anything. So this preloaders thing came in as a precursor step on loading anything related to the app. We were just bringing in Adobe-specific or ecosystem-specific knowledge. Entitlements, again, user profile, reading whether your browser is compatible with the application that we're trying to run. We weren't running in like older versions where WebAssembly couldn't be activated, and all of that kind of stuff. After the preloaders comes in the main bundle, the one you're probably most used to, just making the main bundle that usually gets loaded on the web. But we did have like a dependency container, because remember how I was telling you we had this huge 28 gigabytes of memory that we had to move from desktop all the way to the web? Well, we had to figure out a way where we're dynamically switching between bundles behind the scenes, right? So as our user was using our application, we were reading patterns out of where are you going to go next into the toolbar, right? So it seems like based on how your mouse is moving, you're going towards the rectangle tool. All right, behind the scenes, we would fire up a request, get the rectangle tool for you, load it in memory, and prepare it for you so you can actually use it when you start drawing the rectangle, right? Similar to that, if you open up a toolbar where you were going and editing images, right? You start editing images, you start working with pixels. Behind the scenes, we were looking, okay, you're going for an image. Great for you. Nice, not great for us. You click on the image, you start drawing the image, and you upload it and all of that. Behind the scenes, while you were doing all of that, we were actually preparing the bundle for you and loading it real time into your browser so that you have all the tools necessary in order to edit the image. Does that make sense so far? This is what we use the dependency container basically for, to always be able to swap between these tools. Then comes all the regular stuff of a web app, which is like internationalization, error handling, all of the app stores that we were doing with MobX. And on top of it all, it was just like the beautiful part where we just put buttons and titles and stuff like that on top of it. But now, that's a fine HTML you got there. It would really be a shame if anything happened to it, right? Of course, as I was telling you, this is just the main thread. We were looking right now at just what's happening on the main thread. But in comes the secondary thread, which was the thread of, if the main thread is everything you saw on the page itself, being able to go and click on the button, on the title, and so on, the secondary thread that we were building, that we were running behind the scenes, it contained all of the business core logic that we did. How does a rectangle over a rectangle behave? What is going to come out of it? Are you able to, what is the Z index order of these three different rectangles that you're saving in the document? What can you do with the image? What can you do with a line? What can you do with the curve? And so on and so forth, right? So the second index.ts comes into the background. It initializes a different thread in the browser, and it starts kicking out pretty much a very similar pattern to the first one. Just bringing in the main, the dependency container, it starts creating the nodes. We're going to talk, is anybody here familiar with an ECS system? Yes, awesome. I'm going to briefly explain to you the ECS system at the end if you want. But basically, nodes are, imagine of an entity that can take any possible form. And as you add more attributes to it, it kind of becomes something, right? So those were the nodes for us. You built an initially node, and then you added a text to it, and suddenly it's a text node. You add a color to it, and it's a complex node, and so on and so forth, right? Those were the nodes. We then bring the models behind every single piece of the UI, like when you were seeing X, Y, Z, width, and height. Behind it, there was an app model. It would have been really great if we could have done that on the main thread, but the problem is, as soon as you started moving that thing, we couldn't process enough on the main thread, right? So we actually had to capture all of the events, and we're going to talk about it in a minute. We're going to have to capture all of the events, send them to the secondary thread. You do the computation, move the things around and all of that. And at the end, you just tell me where is my new position on the canvas, right? So those are the models that are talking with us. Then there are just the notifications, which we're just pushing towards the user in order if you get new files and so on. And all of that basically feeds into the app stores over here, which is the state machine that we were talking about earlier. All clear so far? All right, I'm either doing a great job or a terrible job about it until now, but we'll see. It would be a shame if something happened to that schema, right? Well, of course it would happen, because we've talked about 3 of the things that I've talked at the beginning, technologies. We've talked about TypeScript, right? That's all the business logic. We talked a little bit about React and the framework on the front of it. That is all the part that's UI, basically, oriented. But in comes the C++ engines, right? So for each of the more complex operations that you would have to do on the canvas itself, we couldn't compute enough in TypeScript. TypeScript was great at figuring out where is the position on the canvas itself. It was great at figuring out what color my rectangle was. But do an opacity style on the rectangle itself, and TypeScript would be like, please, God, forgive me, right? It would block the entire browser. Like it would just, even with the secondary thread that we were using, it was using so much memory and it was overleaking so much that we would spike from a simple change of opacity on a rectangle. We would spike from like 300 megabytes of RAM used all the way to 1.2 gigabytes because it was just crunching that many numbers in order to figure that out. So what we ended up doing is, okay, everything that is mission critical and needs a lot of processing, we need to offload it to a different WASM bundle. And we started creating WASM bundles for some of the most complex things. One of them was the text engine. I don't know if you know how complicated text is in general. I didn't know until I built this application. But one of the smartest people I've ever worked with, he's a principal engineer. Mihai, if you see this, thumbs up. He's a principal engineer at Adobe. This was the hardest part of the app possible. The number of possible glyphs, fonts, ligatures, distances, and all of that you have to process in order to figure out how to draw those pixels on the canvas in text is absolutely ridiculous. So this was like a separated bundle in itself, which is a C++ WASM bundle for text processing in itself. Then we had the render engine. The render engine would basically take care of all of that opacity, color, collision, how would you change in order to go from digital all the way to print, like color schemes and all of that. That was the render engine bundle. And the path engine, which is basically as soon as you transform something from a simple rectangle, which is easy to compute in TypeScript, but you start interacting with the lines themselves, so you start bending them and creating vectors out of them. Again, that was too much for TypeScript to process, so we had to move it over to C++. So far, so good? Cool. Let's rewind a little bit and draw the whole picture of the 3 different areas that we see, right? The first one is the UI main thread, where we're just drawing the UI, right? We're just throwing some components in there. We're showing the data related to the component that you have selected or anything that you have selected on the canvas. The second one is the authoring worker. This worker is especially focused on everything that is business related, right? So how do 2 rectangles sit on top of another? How does an image look like and what are the attributes for it? And everything that our business or our product managers would come up with in order for us to put in the product. And the last one was the rendering worker itself. Why did this one appear? Initially, we were just using the authoring worker and we were just spawning out that WASM bundle and we were painting on the screen. That's all great and nice until you want to do animation. Now, if you want to run a video, I don't know if you know, but that also takes a shit ton of processing power. So suddenly, we were moving a movie on the canvas, and the movie was not moving, right? The movie was playing, but the movie was not moving. So we had to figure out, like, okay, we need to give the video itself a different worker thread that can spawn up and take resources and process by itself so that we can actually keep the business logic, which is just moving the movie on the canvas, and the actual play of the movie in 2 different threads that will process all of this data. All right. Now, because I didn't confuse you enough up until now, and I talk like on the cloud, I've tried to put together basically a simplified component workflow. It's a lot simplified, but it's enough so that you can grasp the overall complexity of the system. And hopefully, if you want to build something similar, you might find this useful. So we're looking, can everybody see okay? Yeah? All right. So for the main thread, a couple of main concepts that we want to talk about. First is just the UI, which is the components you are drawing on the canvas. We were firing events from the UI, just firing up events. We were catching them at the level of app model. And we were doing something with them, applying it on the state model that we have. Remember, MobX, we were using MobX as a state model, and that would just, through bindings, reflect in the components themselves, right? So let's say I just have a, how is it called, a slider? I have a slider, I take it from point A to point B, right? I need to update the value to point B. An event gets fired up all the way to the DOM. It gets captured by our app model. It's written in the UI state. The UI state then updates the component itself, and it says, hey, you've selected B, right? That's the basic UI flow. We then move over to the authoring worker. The most important piece in the authoring worker is the document model itself. And I can probably make an entire talk about how to create the document model and make it versionable and how to take care of not breaking your document model because it's mission critical, right? But I'm not going to do that. We'll consider the document model, consider it the Photoshop file, right? You open up a Photoshop file with 10,000 or 100,000 or 900,000 nodes. We read all of that and we bring into memory. And that's where we enter in the authoring worker, right? We serialize all of that into memory. We now start working with it. There are a couple of things that appear at first sight. The first one is we need a model for all of this, right? Like we read text from a file and we try to pull it, we put it in some sort of entity that knows what it is and how it's acting. So we have an authoring model, and then associated with this model, we need to link this model all the way to the app UI. So we have to make some transformers basically that take the model, the object itself, and transform it in whatever I want to show to my users, right? So this is a flow here, but it wouldn't be easy enough, right? It's way too easy. So there are also edit operations, but there are edit operations that do not necessarily come from my user, but actually come from users across the line. This is where the collaboration model comes into, right? So every single time that somebody did something 10,000 miles from me, I had to receive an event, updated it on the document itself, update the document model, and that would have to flow all the way into my application. So if Andre here tried to modify the color of a rectangle and made it orange, I had to get that event and update the rectangle on my own page, right? That was the flow. And over here, we also have the C++ algorithm helpers, which they would say like, OK, now I want to change my font from Helvetica to Arial. Well, congrats. That's easy, no? Not really. You kind of have to update 70,000 objects with the new font, compute all of the new glyphs that you have to draw on the screen, and then figure out where to draw them, right? So this is where the magic text WASM comes into play. It computes all of that and just gives us like the exact image that we want to draw on the canvas, right? That would also be fed into the edit operations. It would be written in the document model so my collaborators can get it as soon as possible. But then we have to also communicate it back to the UI, right? Because any changes that come from over the pipeline, they also have to be surfaced up in the UI. In the UI, they always come via the view or decoration models. You're going to see that I said view and decoration models. Why? Because the view models are the persistent ones, right? I update something and it's forever. The decoration models are the small dots that you see around the object when you try to rotate it, for example, right? Those are objects that are just me user visible. Nobody else sees them. Those are not persistent objects. If I do something with them or if I interact with them, that's not going to be persistent over the wire to the other elements. So you're going to see over here a UI sync. But I'm going to tell you in like 5 minutes what that UI sync does. Moving on, we have the authoring worker, which is basically all of our business model, that all of it surrounds the document model. The document model is the ultimate source of truth. He's the decider of what is the reality, basically, for this document. Then we have the UI itself, which is always surfacing the information in the document model. But we need a couple of things more. The next one we need is the actual render worker, right? Like we move all of this information, like I like to say it, we take the JSON from here, we put it here, and it's an easy enough job, but then you actually have to make something pretty for the user. So in comes the next C++ bundler, which is the rendering worker that it's in itself its own thing. And this C++ bundler basically takes care of everything that is around scene graph, scene and display compositors. Again, I could probably do a whole talk about display compositors and scenes and how all of that plays together, but very high level. Basically, every single time you interact with an object, you get its business state and the derived state that you're getting from the renderer itself. To give you an example, whenever you click on an image, right, you get all of the business state, which is like the URL of the image, what base64 image maybe is in there, what properties have you applied on the image, maybe you put a transparency, maybe you put, I don't know, some sort of overlay or transform or anything. But afterwards, you also get the transformation which are specific to your screen. Let's say you actually have problems seeing some colors. So you're using some sort of mechanism in order to find all of this more, to make all of this more accessible for you. Those are transformations that are not persisted for the document and for those across the wire, but they're only for you. They're only oriented for you. So if you have trouble seeing between red and green and you want to encode them in some other colors, you can totally do that. And the renderer engine is basically what's going to take care to overlap whatever decisions or whatever user decisions you make in order to present that information towards you, but not towards the other people that are working with you. Does that make sense so far? All right, cool. This all communicates via a change queue. You just, basically similar to event bus, you just drop events in there, and the renderer is going to take care at its own pace to basically update your screen. And of course, on the right side, there are any external services that you have to communicate with. I don't know, this is the payment build, the payment gateway, some Unsplash integration that we had, or whatever else. Any questions on this diagram? I'm going to give you 5 seconds, and I'm going to try to drink some water if I can find it. Cool. Is this useful? Surprisingly, yes. I feel like you have a bad impression. You made a bad impression about me. And now it's all right.
I'm really not that great at web development. Most of it goes over my head, but it's, oh my God.
All right. Cool. So this is the simplified component workflow. Behind every single one of these small things, there's like a whole thing that I could be talking about. But this is like the high level enough so you have what to work with. Now we're going to move a little bit, and we're going to deep dive into that UI sync part that I was telling you there. And I'm going to try to explain to you why we ended up doing that. Basically, when you start building an online editor, the number one thing that you can say for sure is that you have no idea what your user is going to do with it. From drawing cats to, I don't know, creating animation, birthday cards, or whatever, you have no idea what they're actually going to be doing with it, and you have no idea how they're going to interact with it. So all of the objects that you're going to be creating should be as flexible as possible for them to express their creativity. So in comes the ECS system. The ECS system is very popular in game development usually, but what it means, rolling back a little bit to what I was saying previously, is you create a node that is basically whatever it wants to be, and then you just attach attributes to it, and that's how you define what it actually became, right? It's a little bit of a shift of paradigm, but I have an example for that at the end. If you want to go through the flow, that's totally optional, of course. But on the authoring side, we basically had these generators where every single time that we would read something from the document, the generators would take it in and would look like, okay, so this is a JSON. Its type is a rectangle, and then it has property X, Y, Z on it, right? Out of that, it would create an object, a JavaScript object, with all of this information. But then it would look like, okay, for the type rectangle, I have a couple of functions or a couple of things that it can do. So it would go to our model of things and just attach that model to the object itself, so you can actually interact with the object and just invoke those functions on the object itself. Does that make sense? It's basically composition of that object into what it should be in the end. And on the other side, there's basically the handlers. Every single time that the user would interact with it, with something, it would receive the information of the updated state of the object. It would serialize it in the ECS. And then the generators would be, this object has been changed in the last tick. Are you familiar with the concept of a tick? Yes? Some of you. Basically, a tick is like, it's not a second because it's too much of a second, but every single operation that your computer is doing is basically a tick. You can imagine it like this. And a tick is just like, imagine you have 10 million ticks. A tick is just the smallest unit of time from point A to point B. Does that make sense? As much as possible. All right. So we had all of this all the way here, the render component that we're actually seeing on the UI. The render component would talk with what we were calling a smart component, because creating a component on the authoring thread was great. But when we moved it all the way to the UI thread, we realized, but we want to attach to this component another 10 other behaviors, right? So in order to do that, we were basically taking that initial component and we were just composing it with even more behaviors that it could have based on the app that you would open it in, right? Because if you opened it in Photoshop, it could do like 10 things. But if you open it in Illustrator, it could do another 5 things. So based on that, we would just attach to that object more and more behaviors that it could do. The component state is basically just the view of what the generator here is creating. And the store itself, imagine it, for example, the store of layers, right? That would store all of the layers with the name and everything that you have in the document. Also, you can imagine a store being as all of the colors that you have in the document. We just do an ECS query. I'm going to explain to you what an ECS query is. We're going to see all of the colors that you have in the document, and we're going to present them to you in a component. That's what the stores would basically have. Now, why the UI sync here? Well, the UI sync here comes from a very specific problem. The problem is the moment when you're leaving from the authoring thread and you're going over into the UI thread, the browser serializes and deserializes your object, which is great if you wanted to serialize and deserialize your object. But the problem with serializing and deserializing your object is that we found out that all of the functions that we were attaching here in the generators were suddenly 7% out of the time corrupted to some degree, right? Like the function itself would not be able to self-execute once we were moving over to the main thread. So we found out like, hey, this is like tough life. We are getting that serialization and deserialization, and what's more, that takes a lot of time. So you would always get a little bit of lag before getting the actual object to your, from the document model all the way into your UI. What we did with the UI sync is we basically created a predictive model. If you click an image, you're probably going to get a couple of attributes on it. So before we go all the way to the authoring model and actually figure out like what you're going to get from the authoring model, we're just going to presume you get this. Like take all of these attributes, attach it to your UI or whatever you're doing, and that's what you're going to interact with at first because you're not going to figure it out. But then whenever we have the confirmation from the authoring thread with the actual data that we deserialized, then we're going to enrich your object so that you're looking at the actual object that you've clicked on. Did that make sense? Yes? Ish? All right. Cool. And the last bit over here, I told you about that dependency injection system that we were having. We were basically enriching the store and the smart components with things such as internationalization. We were bringing in an accessible canvas that we were attaching to the canvas itself, and a whole lot of other systems that, again, probably each of them is worth a talk in itself. Cool. Moving over. Who's tired by this point? Yeah?
I want to clarify something.
Yes, please.
I didn't want to say surprisingly yes because I didn't expect it would be useful. I was just surprised at the complexity.
Oh, no worries. Yeah, no worries, mate. I'm just teasing you. That's not a problem. No worries. All right. So I basically chose to do like one of the first problems that we had is multiplayer is basically complicated. So we were like, okay, how are we gonna deal with this? And freaking multiplayer, man, this is like probably the most used expression that we had for a couple of weeks in my project as we were trying to build this. But we came up with a delta management system. And I'm going to try to explain it to you a little bit. So a very simplified version of this problem is like this. User A takes this helmet here, and they change the color to red and send it over to the server, right? Easy. User 2 here changes the helmet color to green, and they send it over to the server. All that is good. User 1 and 2 start moving the object up and down, and they send it to the server. The question is, who's right? Initially, we would just presume like, well, whoever is last is right. But, surprise, surprise, we didn't account for network lag. We didn't account for you not being connected enough between the two of you so that we actually figure out who is right between you two. So last in on the server was actually not necessarily the last person that did something. And that's how we came up. So basically, both users were seeing their objects just jump around. Like I was interacting with my object, I was just dragging it around, but suddenly it would jump up on the other side of the page. And we were like, yeah, that makes sense. It's just a feature, it's not a bug. You just have to catch the object again and move it over where you want it. Or, of course, you would just try to change the color of your object to blue, but somebody over the line was just holding the color on red for you, right? So every single time you were actually changing to blue, somebody over the wire was saying no red. And you were going to blue and they were saying no red. So all the time you would get this freaky behavior and you wouldn't exactly understand what the hell is happening. So I'm going to bring you to our solution from two perspectives. The first one is for a persistent kind of property, which is like color. And the second one is going to be for what we call an, I hope I pronounced this right, ephemeral change, which is basically a change that is not forever, or it's still ongoing. So the first one. Step one, both users open the project. Step two, they start doing some change. What we ended up doing is basically we took change number one and we moved it over to the Delta history system. That's what we called it. Then afterwards, you had to wait for a confirmation in order for your object to be persisted on the document model itself. Until you would get that confirmation from the server, you changed the object, but did you really change it? Not really. So saying that, so if in this scenario, if the server got disconnected, your change would be somewhere in memory, but still not committed to the document itself, right? Then then we take change number one and we push it out to all of the listeners out there, all the other planes that you're playing with. So on all the other planes, we're saying, okay, we acknowledge that change one came into the Delta history system. Everybody has to apply change one and then take their own local stack of changes and apply over that change, right? So we would take change number one, we revert whatever, in this case scenario, the change number two, but it could be like a whole stack of changes that haven't applied just yet. We would revert all of that behind the scenes without showing anything to the user. We would apply change number one over, and then we would reapply your entire stack of changes. Does that make sense? And moving over, it's pretty clear. Change to Delta as soon as the user would decide on the color and they would try to commit something to the document model. It would be moved over to the Delta history server. That Delta history server would then send a message to the first user saying, OK, now you can apply change number two Delta. Does that make sense?
Question.
Yes.
What happens if you have latency in confirmation?
Latency in confirmation. So your stack is not. Your stack of changes is not committed to the document model itself until you get the confirmation, no matter how long it takes. If you have 7-second delay of confirmation from the server, if somebody in that 7 second opened the document somewhere else, they're not going to have your change over there because it hasn't yet been committed to the document itself. Does that make sense?
And then your change will be reverted when the other changes are going to...
Exactly. So your change would be reverted. If there was changes before that 7-second window, they would all get applied. Your change would be applied then, but at the same time, you might get a surprise where somebody else changed that property in the meantime. So you wouldn't even be seeing your change. You would actually see the override that's coming from another user. Does that make sense? Yes. How many game developers? One, and he had no experience with anything else than rendering. He was the rendering engine mastermind. I think that's why it took us so long to figure these things out. Because if we had a game developer, he would probably just tell us right off the bat that you're...
Basically like compensation.
basic lack of compensation. We read a whole shit lot about that, but we had no idea before building this, basically. Yes, it would have been extremely useful if we had someone with a game development background, but it took us a lot of time even to figure out ECS out, right? Because initially we were like, okay, we're just going to create a rectangle, create class rectangle, add a bunch of properties, add a bunch of functions on it, basically to be able to do it. And then we were like, but we want a rectangle that's a bit special. And we were like, okay. So we create another class from that rectangle class and we make it a little bit special. And then they were like, but we want one even a little bit more special. And so on and so forth. And that's when we started basically doing some research and figuring out like the ECS system is probably what we need here in order to be malleable enough for everything that our product managers could come up with.
So it wasn't a performance issue they were solving?
No, it wasn't a performance issue. It was basically just we had to increase the complexity of our objects exponentially very fast. And the ECS system was the easiest system. Well, it wasn't the easiest because it took us a whole shit lot of time to learn how to use properly because we failed at first, of course. But it was the easiest system that could adapt fast enough to how we were changing the product. Imagine that in less than 7 months, we had the first MVP out. And in the first 3 weeks, I swear to God, I got 5 messages every single day with the PM saying, I had an idea. With changing how an object behaves or changing how a decoration behaves or something like that, right? So initially we were just updating all of that and just updating and updating and updating until we realized it's not scalable. So the guy that had experience in game development, he was like, I'm going to ask one of my buddies what's up with this. So we started getting to know about ECS and about how you apply systems over entities and all of that. But if you see that I'm guardrailing anywhere around ECS, correct me, please. Okay? Yes?
I have a curiosity. What happens if user G
Yep.
deletes the object, and then on what do you apply back those changes?
On what you apply?
The web user deletes the object. You still have a stack of uncommitted changes.
Yes.
That
Yep.
your object disappears.
Mm-hmm.
What happens? Like, is a message the object is deleted?
Right. So no, so are you referring to what happens? I'm going to go with both. So as soon as you get the change from the Delta history system over to the user itself, we're filtering the ECS by the ID of the object. So we see that the object is no longer there. We're just dropping all the changes, right? If you're referring to the fact that
What happens if someone deletes the object beyond another user?
in those 7 seconds, the result that you're going to see is basically we move over, we bring in the, so you haven't gotten the confirmation yet, right? From those 7 seconds. You get in the changes, which tells you the object is deleted, right? We delete the object. The next time the system runs from the Delta history, I get the confirmation. I try to apply the confirmation on the document model itself, but the entity with that ID no longer exists. So you're not going to get an error or anything. That's the moment when your object actually disappears on the canvas. Does that make sense?
That's one hell of a system.
Yeah, that was fun to build. All right, so this was for persistent, right? This was the easy part. The complex part, we change to now a confirmation, and we move over to the ephemeral state. Now, why was this more complicated? Because user A starts dragging an object. User B starts dragging an object. But they're still dragging it. 5 minutes later, for some whatever reason, they're still dragging it, right? Like initially we were like, this is easy. Just like with the other one, we're just sending over the delta, and then we get the confirmation, we apply it on the object, the new position, surprise, you get it, right? But then we find out like you were dragging the object, and suddenly your object would jump from your mouse because you would get another commitment from another user that would say the new position of the object is somewhere else on the canvas, right? So you couldn't actually do that. You had to have an intermediary state. So we invented the ephemeral forwarded changes, which means basically every single time that a user did a drag, for example, user B did a drag, we would actually send every couple of milliseconds an update over the wire, and we were creating another stack where we were having the user B position where they are on their end, and where you are on your end with the same track, basically, if that makes sense. So user A would see user B as first position, and my changes are overriding user B. User B, on the other hand, sees the real position as user A, and my overrides of the position of how I'm moving the mouse as the confirmed position for me for the moment, right? User B continues to drag. You get user B drag number 2. Again, we were throttling this, so we were sending it every couple of milliseconds. And then we would apply the user A drag, which is like the latest position you were dragging your object to. As soon as user A releases the mouse, well, something else happens. User B continues to have a drag on it, right? So you still have that position behind the scenes. But now I have my applied position. But my applied position is still not confirmed because the other user is actually doing something. So we're sending an applied position, user A position to the server, and we're getting that congratulations, you applied it. Now we can consider that successful and apply it on the document model. So if somebody else, a third user, opens up the document now, and they actually get the whole position serialized, they see the last position that me, user A, dropped the object to, right? Not where the user B is still dragging the object on the screen because they're having fun with it, right? So that's what we ended up doing. As soon as the user A applied the position, we basically wrote it on the document model itself. We consider it applied, and then we overrode the position with user B position. Because why? Because we want to see live 15 minutes. Okay. We want to see live how user B moves the object as soon as you release the mouse, right? So if until now, if I was moving the mouse, I'm not interested in what user B position is. As soon as I release the mouse, now my object can actually start moving on the canvas with how user B is moving it. Does that make sense? So instead of this ephemeral change of user A being the top most important position on the document, suddenly user B drag over the wire becomes the most important position in the document. Similar, basically, as soon as they get that application, behind the scenes they get a change. It is written on the document model itself that the new position for user A is, for this object is somewhere on the canvas, but user B is still dragging. As soon as user B releases the mouse, we send an apply user B position over to the canvas. Similarly, we get back the answer. We apply position A, which is what we did over here. We then apply position B. This is the new reality of the world. But of course, as soon as we apply position B, we also have to communicate it over to the other side and apply position B, over to user A as well. Questions on this one? Oh. So close. Yes, please.
I think I kind of understand the thing you try to fix here. It states both ephemeral or not. But what about the usability perspective? For me, I'm not sure how often is happening this use case. 2 or 3 users are working on exactly the same object. But for me, it's very strange. User A is putting one color and starting to move it, suddenly it's a different color. From the usability perspective, how did you show to the user there is multi-player game? You are touching something, somebody else is touching. How do you solve this problem?
Yeah, exactly. So basically, every single time you would interact with an object, the faces of the people interacting with that object would start appearing on the top right corner of the decoration itself, right? So you would know that 5 different people are interacting with that object. We don't want to make the decision of locking an object. That was the #1 thing that our product didn't want, because that would have been so much easier, I swear to God, right? But they were like, no, we want every single one of them to be their own special butterfly and be able to do everything on the same object. And the problem becomes whenever you have complex groups, right? Because if 2 different users are interacting inside the group, then you have a contextual interaction, which is also like every single object on the, like the group itself has a number of faces on it, and then you have the object themselves, which are also interactable by different users. So you get this kind of hierarchical blocking of objects, but again, we didn't want to block the objects. So as soon as any two users would interact with the object, behind the scenes, we were creating some sort of contextual interaction, or like an enclosed space in which you were working, and we were trying to solve conflicts with whatever else somebody else was working.
Regardless what EM wants or the developer wants, try to test it with the user.
Yes, yes, absolutely.
What are the real use cases?
Yeah, so as we were building the MVP itself, that's how we ended up with, I want to be my own special butterfly. Initially, we were just locking objects. So if somebody starts interacting with just this object, you can no longer interact with it. But apparently, people start interacting with an object and they leave to have their meal. So what do you do then? You can either time out after a certain amount of time, like 3 seconds or 5 seconds or whatever, but surprise, surprise, people were unhappy with that because they were expecting that whenever they come back, the object is not changed in any way because they were locked on the object itself. So after numerous user interviews, like our product and designers were always doing user interviews with them, what's the word here? Undisputable result was that we want to give all of our users the capability to interact with objects at the same time. And that's why we had all of this fun. Yes. Stefan, you were saying 15 minutes. Is that a hard deadline? 10 minutes. Okay.
So we have time for networking because we have booked the venue until 9.
Okay. Now, this is like the first end of the presentation, but I also have like 2 Easter eggs, if you want. The first one is foundation of ECS, so I can high level explain you what ECS is and how it works. And I also get some help here to correct me if I get anything wrong. And then there's like another small exercise. Do you want to go through these, or do you want me to answer any sort of questions? You want to know what the ECS is?
Well, I've been using it for such a long time and I never knew that it had a name, so.
Okay. Okay. Let's see. So we do this? I'm going to try my best to explain ECS. Spoiler alert. My best friend at the time was the ECS documentation itself, and I'm pretty sure that I'm going to mess something up as I'm explaining this. This is meant to be a starting point for you to get interested in ECS and then go on your own side quest and figure out like how it works properly. Do not take anything that I'm saying 100% granted, okay? Cool. So, foundation of ECS. The problem in itself is that you have a hierarchy of objects and of attributes. Imagine this is the object itself, and I start making it out of pieces of puzzle, right? But those pieces of puzzle on themselves also have some properties, and their properties have some properties, and their properties have some properties, and so on and so forth, right? And it all looks nice and dandy, and you start modeling them into a class, because that's what you do, or that's what I did initially. Yes? ECS, Entity Component System. Thank you for reminding that. Right, so there are 3 different things: entity, components, and system, and we're going to walk through each of them in just a couple of seconds. So the problem from which we started is basically, again, we have this object, we bring some attributes onto it, we tell it it's a rectangle, but the rectangle has some attributes, and then the attributes of the rectangle, like the color, has also some attributes which are like the hex values of the color, and so on and so forth. Surprise, surprise, of course, because you always want to grow your application, there are new attributes that come to those objects, right? And you have to attach them. The easy way out is simply just add another attribute, add another function, or so on and so forth. But then you actually have to delete some, because from now on, rectangles no longer support borders. Why? Because our PM said so. Because they did like extensive user interviews and everything, and nobody likes borders on rectangles, right? So we're removing borders on rectangles. Or any other example such as this. Like we're starting to remove attributes from our system. All right, but you know what? This attribute over here, like 3 levels down, should influence this other attribute on level 3 in case they change something on it, right? So if they come onto a rectangle, they double click on a path and they start drawing the path. Okay, I'm interacting at the path level, but since I'm interacting at the path level, suddenly it's no longer a rectangle, right? It's some other object because I just changed it. I'm deleting a point. Suddenly from a rectangle, it becomes a triangle. So deleting a point, which is an attribute like 5 layers down into the object itself, suddenly mutates the object itself from becoming a rectangle to becoming a triangle. Does that make sense? So that's where we kind of came into the world of ACS. We were looking around like somebody did something around this, right? Like we're not reinventing the wheel here. It's probably, like, yes, it's a complex application, but there are smarter people out there than we are. So let's start looking into this. So we got into the foundation of ECS, or we started understanding what ECS is. And ECS, very simple, is you get an entity, which is like, imagine an ID, a simple ID. Imagine a JSON, just an object with an ID on it. That is an entity. You have no idea where this is going. This is point 0, right? As soon as you start figuring out what it is, so you take that entity and now you click on the button to make it a rectangle and you click on the canvas. Attached to this ID comes in a component which is a rectangle. This component has traits, tags, and archetypes. 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 Thank you. All right. Now, you're starting to enrich this entity, and it becomes something more, right? Like it gets all of these traits, which are like attributes. It gets all of these tags, which are, imagine an easy way to figure out what it is, basically. And an archetype, which is like, what class is it belonging to, right? And we move over to the other side. And on the other side, on all of these entities, we're building systems. Systems are basically queries or behaviors that can be applied to certain conditions. And this is where the mentality needs to change a little bit, right? Like you no longer have an object that knows how to do something. You have a system that's taking a number of objects. It's looking for certain things on those objects. So it has to accomplish some conditions. And as soon as all of those conditions are fulfilled, you know you can do something. You can apply that behavior to that particular entity. Did that make sense? I have an example that probably might make it a little bit easier. So we start from an ID on the object itself, and then we start figuring out attaching components to it. So in this scenario, I picked up Sheldon because I love Sheldon. And starting from the point where I, again, like 2 years ago, I realized that I have no idea how programming a large-scale thing looks like. We start attaching to this thing here a couple of things. We attach borders to it. We attach some boundaries. We know this is how big the object is. Approximately, my laser is bad, but you figure out, right? We attach a fill. This is the fill here, Sheldon, because he's awesome. And then we attach some render info to it. And the render info, if you remember, is all of the additional information I need in order to put it on the page itself, right? On the other side, I have a couple of systems that are now suddenly working on this entity, which is compute boundaries. Why? Because I have a component with boundaries and with all of the attributes necessary in order to compute boundaries, right? Then I have draw on surface. Why does that work? Well, simple, because I have a render info. As soon as I have a render info attached to an entity, then I suddenly know how to show it on the screen. Until I have it, I don't know how to show it on the screen. And if somebody would ask me, draw this on the screen, I would just drop it and don't know how to draw it. Does that make sense so far? Yes?
So basically, let's say you build up a node and you add different components to it, and all of these components either have or basically trigger a bunch of backend functions.
They don't trigger the backend functions. That's another thing. You trigger the backend function whenever you interact with the system. That's where the system comes in place. And what you do is you run a query. So I have a selection, right? And I selected 3 objects in it, right? The moment when I click fill, in order to fill those objects with something, I want to change the color, for example. Two of the objects actually support color changing. One of them doesn't. So what you're going to do behind the scenes is you're going to say, I want to trigger the change color system. What it does, it has behind the scenes a query, which is looking for the attribute color in order to be able to change it. If it finds the color attribute on the object, which would be in this scenario a component, right? Because the color is like a hexa, it has multiple information behind it. So if it finds the color component on the object itself, then it makes the query. It actually gets into the query. So out of the 3 objects, we now only have 2 objects on which we can apply the change. So my system ran the query. It's backwards, basically. That's why I was saying that it's a paradigm shift. You no longer know what you're applying it on. You're just hoping that whatever you want to do is going to get applied to everything that is compatible with what you're trying to do.
So yeah, basically, in this case, it would be considered I've never properly used the query. So it's basically parses through all of the tags it might have, and depending on those tags, it triggers what it needs to do for the function.
Components, tags, or archetypes. Remember, there are 3 types of things, right? Components are basic attributes. Tags are ways that are non-meaningful that I would tag an entity with, right? Like, you don't care if this entity is named Aleodor, right? At a system level. But there might be some system out there that needs that tag in order to be able to apply something to it, send it over the wire or something. So tags are usually, if components are attributes that actually surfaced on the object, they're of interest to the object. Tags are things that are like very non-objecty.
Yeah, it's something like most probably a user would define
Exactly.
an object.
It might be something like that dies after 5 minutes or 30 seconds or whatever. And then you got the archetypes, which is like the class in which this is, making part of, which is a quick way, it's basically a quick query on some sort of things. And I'm going to try to make it a little bit cleaner as we go through the slides. Again, this is the best that I could think of. If I transform this to an arrow, suddenly I have another component attached to it, which is direction. Now I can actually use the system which is called change direction. And if I would do a query on this object, it would turn out true. It would return the object. So now I can apply change orientation, and the direction component would be altered as a result of that. Moving it over a little bit, because I love Sheldon, I wanted to end it up nicely. I'm removing borders and direction. As soon as I'm removing borders and direction, whatever query I'm doing on those objects will no longer surface this object if I want to apply a border or change the direction. Does that make sense? I think I can do better. I just had a couple of ideas how to do this better, but you're going to have to stay tuned. 0 minutes. That's do me like. Basically, very easily, the last thing I'm going to say is you have a bunch of in-memory selected objects. Right now, we're looking at a rectangle, at an arrow, and at a heart, right? These are the entities that I've selected. I've dragged them around these 3 objects. Then what I'm going to do is I'm going to say I want to change direction to right. What's going to happen behind the scenes? As soon as I want to do this, there's going to be a query execution that's going to look for the archetype that has a component direction. So basically what's going to happen, this system is going to go over here and is going to look over every single one of these entities and see whether it has the component direction on it or not. As soon as I get this query result over here, I can now execute whatever behavior I want for a component that has direction. In this scenario, I want to execute the function align pointer to the right, which means basically that I'm pointing this coordinate to the right. Another couple of things might be applied here, like as I align pointer to the right, I don't know, maybe I have some side effects to this component just to make it a little bit broader. But then on step n-1 here is I'm going to execute the query for renderable because I want actually to show that arrow changing from left over to the right, right? Like as soon as I finish up all of my execution over here, the last step that I do is I query all of the objects, I see which one of them are renderable, and I redraw the canvas itself. Does that make sense? I hope so. If not,
At the high level, yes. Not the nitty-gritty details, but at the high level, yes.
again, this is just like a starting point for you to go out there on a quest and find more about ECS. It's a really badass system if you don't know exactly what you're interacting with, or you don't know exactly what your users are building. It's very widely used in gaming. Why? Because between every single foe you find in gaming, there's also going to be an entity that has a health, a form, and everything else. But at the same time, they might have different clothes, right? So those different clothes are actually just different components that are attached to the same type of enemy. Or maybe they have a different health bar, right? But the concept of health bar and the health bar going lower is a centralized concept that works the same for all of the enemies that you're going to be interacting with. Just the number of that health is something that is a component on a component on a component on an entity, right? So the beauty around it is basically that it allows you to compose any kind of complex object from a very core behavior that you want to be defined, which is a component. And of course, all of these components should be composable between themselves, but that's another story for another presentation. I thank you very much. A couple of things. Entity components. Very simple. Entity and components, very simple to remember high level. They're free form objects, and I use Ditto here. I don't know if you know Pokemon, but Ditto was able to turn into everything. Basically, that's what an entity is. So they're free form objects ready to fulfill whatever role you want to attach to them. Queries and behaviors, there are systems that execute on unknown data clusters, and they get the result based on whatever is in that query. And lastly, this shines in highly unpredictable data-oriented setup. Whenever you're trying to model something that you don't know, but you have a lot of information about that don't know what you're modeling thing. That is all. I need to drink some water. Thank you. Mai e cineva care vorbește engleză?
Care nu vorbește.
Care nu vorbește română, scuze.
Da, nu, n-am oprit înregistrarea, e ok, e în regulă. Da, mulțumim, Ale, excelent, super. Mi-a plăcut foarte mult. Oricum o să mai văd o dată înregistrarea când editez video. Exact. Dacă stai un pic să fac un switch la laptop. Așa, că o să am nevoie să arăt niște chestii. Așa. Ia să vedem. Așa, o să meargă un pic cam repede astea până și intră în ăla, nu nimica. O să am rugămintea de la voi, dacă ați venit via meetup.com, să completați formularul de feedback în cazul în care îl primiți pe mail. Mă ajută pe mine pentru organizarea evenimentului. Și încă o chestie foarte, așa, mai surpriză să zic. Am 2 licențe gratuite de 1 an de zile de la JetBrains. Și am să le dau random la cei care ați venit via meetup.com, că e mai simplu să aleg de acolo lista. Așa, deci asta a fost o mică surpriză. Și cam atâta. Vă readuc aminte, în iulie și august nu ținem. E vară, toată lumea în concediu chestii. Ne revedem în septembrie. Cam atât am avut de zis eu. Mai putem să stăm la networking până la ora 9. Avem niște chestii de ronțini, ceva de but. Am uitat stickerele, dacă vreați stickere să luați cu Sibiu Web Meetup, din păcate le-am uitat acasă. Erez oare erez. Atâta, mersi că ați venit și o seară faină în continuare.